relative percentage value should be deviated, right? If you have any problem in the last class, right? Okay, we can go through in the analysis, right? In the analyze menu, the third one, frequency descriptive, is over. Now we can go to the third one, explore, right? Explore, right? If you can choose this explore, before that I want to discuss what's the output, no? See, in this help window, go to the case studies. So in the case studies, exploratory data analysis, right? Say exploring data can help to determine whether the statistical technique that you are considering for data analysis are appropriate. So the explore procedure provides a variety of visual and numerical summaries of the data, either for all cases or separately for groups of classes or cases. The dependent variable must be scale. Dependent variable must be held. The dependent variable must be a scale variable, while the grouping variable may be ordinal or nominal. So the dependent variable should be scale, right? But the factor variable, we have no problem. It may be ordinal or nominal. With the explore procedure can be screen data, identify outliers, check assumption, characterize different among group of cases, right? So corn crop must be tested for aflatoxin, right? A poison whose concentration varies widely between and within crop yield, right? So a grain processor has received 8 crop yield, but the distribution of aflatoxin, actually I couldn't know the actual name of this one, aflatoxin. Aflatoxin is part per billion must be assessed before they can accept it. So in our example, we want to choose this file. And go to use the SPSS summary. Right, this is the file. This one is the file, right? In this file contain aflatoxin or aflatoxin. It can be denoted by toxin and yield. What about the percentage? It should be varied, right? So aflatoxin and corn yield, right? So the dependent variable should be scale. The factor variable may be nominal or ordinal. In the data sheet view, first 16 variables, toxin and yield, and second 16 variable, toxin and yield, third, fourth, fifth, sixth, up to 8. 8 into 16, total 128 data should be here. Now I wish to check whether, what about the exploratory analysis? So go to the explore, then dependent variable is the toxin, and the factor variable, what about the yield, right? What about the yield? Yield is the factor. So in the table format, if you can see this data, table give the value, yield 1, toxin this, yield 2, toxin this, yield 3. So there are 5 columns, 5 into 2, 10 columns, right? It 5 into 8, not 5 into 8, 2. Up to now, the mic is muted. You are not hearing my voice? Hello? Just I have seen my mic is muted. I don't know how long it should be muted. So in this way, we can work out the exploring window, right? So in this explore window, we can get, so I can repeat the thing again. So no more in this. Can you see my mouse pointer and the window?
Yes, sir.
Yes, sir.
Okay. Okay, say reset this thing, and the toxin, that is our dependent variable, right? Cone yield, yield 1, yield 2, that is the factor variable. Statistics, so if you want outlier or percentile, you can choose, right? Plot, histogram, if you need histogram, then you can choose, otherwise no need. Power estimation, transform, untransform, no need. So option, exclusive, both statistics and plots, then click OK. In this way, if you can see, the first one, cone yield 1, 2, 3, and zone up to 8. Here the valid percentage is 100 because there is no more missing values for each and every cases. Due to that, the valid percentage and the total percentage remaining same. No more changes. Why? No more missing values. If anything missing, then the percentage should be vary. Say in the description or descriptive, the descriptive statistics for the first group, here the mean, confidence interval, median, variance, standard deviation, everything should be here. And interquartile range, in addition to that, skewness and kurtosis. Up to 8 group results should be displayed. And percentile, 5, 10, 20, 50, up to this percentile. So 20, 50, 75 percentile also here. And finally, the box plot, right? In the box plot, if you want to see the box plot, the middle line is the 50th percentile, right? Or the medium, right? Or the medium, 50th percentile. This one is the 50th percentile. This one is the 50th percentile, right? So, and upper, lower bounds denoted by the low end and the high end. This one is the 25th and this one is the 75th, right? 25th, 75th, this one 50th, right? In this way, the box plot we can draw. So if you go to double click this screen, then you can move to editable window, right? You can take rights to edit, right? Edit. So if you want to color or if you want to put the naming, anything you can use to edit, right? This is the way we can draw the box plot or explore the values. So descriptive, frequency, and explore analysis. These are the very basic stuff, right? In the help menu, go to the case studies, statistics, say t-test, one sample, already I discussed the same question, paired sample t-test, right? Already I gave the example, and the normal example we already gave, and we already tested the paired sample. We'll see another example that should be available in the helping window. one of the most common experimental design is the pre-post design, right? A study of this type often consists of two measurements taken on the same subject, one before and one after the introduction of a treatment or a stimulus. The basic idea is simple. If the treatment had no effect, the average difference between the measurement is equal to 0. Due to the impact of this treatment, no more effect between the previous and after results. What do you mean? The significant level null hypothesis, we can say there is no impact, right? There is no impact is equal to 0 and the null hypothesis hold. On the other hand, if the treatment did have an effect, intended or unintended, the average difference is not 0 and the null hypothesis is rejected. The paired sample t-test procedure is used to test the hypothesis of no difference between two variables. The data may consist of two measurements taken on the same subject or one measurement taken on a much pair of subject. Additionally, the procedure produces descriptive statistics for each test variable, a Pearson correlation between each pair and its significance, a confidence level for the average difference of 95% confidence interval. Right? A physician is evaluating a new diet for her patient with a family history of heart disease. To test the effectiveness of this diet, 16 patients are placed on the diet for 6 months. Their weight and triglyceride levels are measured before and after the study, and the physician wants to know if either set of measurement has changed, right? So there are two things in his paired sample. One is weight and triglyceride level, right? Weight of the patient. In addition to that, what about the percentage? We use the triglyceride level of triglyceride used for this stage, right? So total 16 patients to test these levels, right? So first we can go to see the table name, dietstudy.sav, right? So I can go through. So first I'll complete this one and come back, right? So we can choose diet study.sav file and then compare means paired sample t-test, right? First one, triglyceride level and final triglyceride level. Second one is the weight and final weight. And then click OK, then we can get the results. So if you want to do this, I will go to the SPSS, open the file. The file is available in the name of what's the name of the file? Diet study, right? Diet study. Diet study. Dietstudy.sav. Could you see the screen? Could you see the screen?
Yes, sir.
Okay, okay. So Here the patient ID, age of the patient, gender, triglyceride level 0, 1, 2, 3, 4, weight level 0, 1, 2, 3, 4, right? So in this case, there are 4 different type of triglyceride levels, not 4, 5 different type of triglyceride levels and 5 different type of weight levels, right? So variable view here, the fourth one means final weight, the third one means final triglyceride level, right? So here analyze, compare means, paired sample t-test, could you see this?
Yes.
Independent sample t-test. So analyze, compare means, paired sample t-test. In this paired sample t-test, first we can take the triglyceride level, right? And the final triglyceride level, right? And the second one, weight level and the final weight level, right? So option 95% considering interval, bootstrap, no more bootstrap, that's all. You can click this one. Here, the triglyceride level and final triglyceride level for everyone 16. The triglyceride and final triglyceride level, the value is greater than 0.05. Weight and final weight is less than 0.05. So within that triglyceride level, no more correlation between the triglyceride level changes, but the weight changes should be displayed. Final triglyceride level and the final weight level. So there are 2 different parameters. So one is triglyceride level and weight level. Weight level, we can reject the null hypothesis. The weight, there is a weight changes, and the triglyceride level, there is no more triglyceride level changes, right? So the first null hypothesis we can reject, and the second null hypothesis we can, first null hypothesis we can accept. There is no more changes from the triglyceride level. Second one, null hypothesis we can reject. There is a clear-cut weight changes is available, right? This is one example for paired sample t-test. If you want to ask anything, shall we move? Okay. Right? In the help. Say in the analyze menu, compare means, and then paired sample t-test. Say, could you see in compare means, inside of compare means, one sample t-test, independent sample t-test, paired sample t-test, ANOVA, one-way ANOVA. Everything come to compare means. We can check the mean value of that group, right? So select the paired sample t-test. In this paired sample t-test, so we have many data. So out of this data, we can choose the triglyceride level 1 and the final triglyceride level, right? There are different stages. Check whether, what about the quantum of triglyceride we are using, right? And weight due to the triglyceride level, what about the weight changes, right? So triglyceride level first to final, weight level first to final. Now we can check whether, what about the results. In the triglyceride level, it's not affected. So if you can add more and more triglyceride level or reduce the triglyceride level, is no more impact. But due to the triglyceride, the weight should be reduced, right? So this one is less than 0. This one is higher than 0.05. Here, the triglyceride level, they put reduce the level. The weight is automatically yeah, okay. So we already have seen ANOVA. We can practice some more examples in ANOVA. It should be available in the help session. Could you see? Could you see this window? Yes. Here, one-way ANOVA. You can use the one-way ANOVA procedure to test the hypothesis that the mean of 2 or more groups are not significantly different. So the definition of the one-way ANOVA, t-test, everything is available in the help session. So you can use the one-way ANOVA procedure to test the hypothesis that the mean of 2 or more groups are not significantly different. One-way ANOVA also offer group level statistics for the dependent variable, a test of variance equality, a plot of mean plot, and range tests, pairwise multiple comparison, and contrast to describe the nature of the group difference within the group and between the group. An important first step is the analysis of variance, is establishing the validity of assumption. The first assumption of ANOVA is that the variance of the groups are equivalent. So if you want to test one in one-way ANOVA, we can assume that is the basic assumption. What's the basic assumption of our one? The variance are equal, right? Variance of the groups are equal. This example illustrates how that test is performed, right? In this case, we can go through a sales manager wishes to determine the optimal number of product training days needed for a new employee. So when we plan to recruit some employees in our company, what is the optimal date? What is the optimal date, or what is the feasible date of training is needed? Because 3 months training, 6 month training, 15 days training, 1 week training, 3 days training, number of training we can give. But what is the most effective date of training? That is the test variable. He has performed score for 3 groups, employees with 1, 2, 3 days of training. The data are in the file sales performance.sav, right? We'll see the sales performance SAV. Next, go to the graph chart builder. So why we go to chart builder? Normally in the ANOVA test, we want to go to the data analysis, compare mean, one way ANOVA. Why we go to graph chart builder? Because chart builder, we want to see the variance are equal or not equal, right? Variance are equal or not equal. So here in this example, normally in ANOVA we can assume the variance are equal, right? The first assumption, variance are equal. So no need to assume the variance are equal. If you want, you can check whether the variance is equal, right? The variance is equal. So we want to prove the variance is equal. Due to that, graph chart builder, go to the chart builder, then you can see this type of screen, right? This type of screen. So in this screen, the values should be displayed here. Here the bar and the type of different bar should be displayed here. The score of training exam. Score of training exam. It should be displayed, the score should be displayed, and exams should be displayed here, right? So in the gallery tab and select bar, drag and drop a simple error bar, drag and drop score on training exam onto the y-axis, right click sales training group and select normal for the measurement level. Drag and drop sales training group onto the x-axis. So this is the way we are represent this one. So we will return back to our SPSS window. So now I choose the SPSS window. Before that, what's the name of the file?
Sales
Performance.sav. Right, good, great. So sales performance.sav. I wish to open the file, open, data, sales performance.sav, right? Sales performance.sav, that is the file. So in the variable view, only 2 variables. One is group and other one is performance. Group means sales training groups. Score on training exam, right? Both measurements are assigned scale variable, right? Scale variable. Here, group and performance should be displayed, look like this. Group and performance should be displayed. So there are 3 groups, total 60 participant, right? Total 60 participant. In this case, every participants are same, but normally in ANOVA, no need to check the equal number of participants for each group. Unequal number of participants also we can allow. Why we can allow unequal number of participants? Because we are only check whether the mean of that group, not the anything else. We are only check the mean value of that particular group, right? So first go to the chart builder. The chart builder dialog box should be displayed look like this, right? The chart builder dialog box display look like this. So then click OK. Then click OK. Now you can see the chart builder dialog box here in this training group and performance, right? So in this training group, I wish to change the data is nominal, right? How we can change the data variable? Right click here and display what type of variable if you want to choose, then you can choose nominal, ordinal, scale. It's already available in scale. Now I choose that is the nominal, right? So go to the bar, active the bar button, and there are so many different type of bars available. I can choose the simple error bar, drag and drop, right? Drag and drop. Here, sales training group, that is the x-axis. There are 3 categories, group 1, group 2, group 3. And score for that category, drag and drop, that should be available in the mean training score. So if you want, say mean, median, mode, maximum, valid, what do you want? You can choose, right? Standard error multiplier 2 and apply. And in this option diagram, you can see nothing. Okay, and then click OK. So this is the graph. What is your understanding about this graph? In this first group, sales training group 1, what is your understanding? Say in the first group, the variance initially when they came to the training program, different discipline of people, different knowledge of people, they will be in the class, right? So different discipline, different knowledge group, they will come together. So due to that, when they came very first day, if you gave the exam paper and got the marks should be varied minimum to maximum, comparably long length. Why? They have already different knowledge level, right? So the variance should be high. Why? They came from different discipline, different knowledge level. But in the second test, what about the second test? What about the second test? Compared to the first exam, the second exam marks go up. What do you mean for that? The training program should be effective. The training program should be effective. Why? Why you can say the training program should be effective? Because the participant, they got more marks from the first exam, right? Is it the only way the participant get more marks, then the training program should be effective? So most probably the paper tough remaining same or the paper strength remaining same, marks going up, the simple reflection, the training program is more suitable or more worthful than the previous one, right? So they got more marks. Due to that, the training program is effective and the variance is also comes to shrink. How can I say the variance is reduced? How can I say the variance is reduced? Please let me open your mouse. Otherwise, I am the one and only one person showing everything, dying everything in my side. What do you feel? How can I show? How can I tell the training program is effective? Hello.
The value is increasing, sir.
Yeah.
At the same time, the variance is reduced.
Yeah, that's the thing. That's the thing. No. So the training program exam marks score is moving up, right? This level is closer to 63 or 64. This level is closer to 70, 72 or 73. This level is closer to 78 or something, right? The marks is moving up. At the same time, the variance is comes to reduce, right? So first assumption is okay, right? First assumption is okay. Then move to the, give me 1 minute, 1 minute. Right? In the one-way ANOVA, the factor variable and the grouping variable. So here, what's the grouping variable? That is the factor variable. What about the marks, exam marks? That is the dependent variable, right? That is the dependent variable. Contrast, no need option. So if you want descriptive, homogeneity of variance, select these things and click OK. Here, the mean value for the first group, 63.57, second group 73.56, third group 79.27, standard deviation 13, standard deviation 10, third one standard deviation 4.4, right? Minimum maximum is also reduced. 3286, 4789, 7179, right? Test of homogeneity of variance, it should be significant. So within the group, between the group, the significant value is equal to 0. Then we can reject the null hypothesis. There is a clear-cut mean difference or mean deviation is available between the 3 groups, right? So only one-way ANOVA we can focus up to this. Apart from this, go to analysis. Which mean value is deviated from the rest, then you can go to the post hoc test. So Turkey or Turkey B or Dungan, whatever method you can use to compare the test. Post hoc, click OK, then click OK. So the same results will come here, significant. In addition to that, post hoc test, homogeneity of series. Here, sales training group 1 is here. Sales training group 2 and 3 are here. What is the meaning for this one? The group 1 is deviated from the second and third group marks, right? The first group is deviated from the second and third group. So in one-way ANOVA, we can simply say there is a clear difference between the mean. That's all the one-way ANOVA. We couldn't say more than that. If you want to say which group is deviated from the rest, then you want to do the post hoc test. In this post hoc test, the results will come, the subset, this one is deviated from the rest of the two. Could you understand what I say? Oh, in my way I am going, you are coming on. What's the thing is going on? Hello? Hello? Participants are here?
Yes. Yes,
Or
sir.
participants are in the dormant state? If you already heard about the term postdoc, no? If you already
no,
heard
sir.
about the term postdoc,
No,
or not?
No, sir.
no, sir.
බොරු වචනය කියන්න එපා. So then, in your one-way ANOVA, when she taught this subject, she never told if you want to find out which group is deviated from the rest, then we want to do the post-hoc test. No one say in your classes. Anyhow,
No, sir.
it's up to you. So if you want to find out in which class is deviated from the other, we want to do the post-hoc, right? Say, if you heard about the term Dungans or Turkey, these names, are you familiar or not familiar? Here,
Not familiar.
for LSD, Latin square design, Turkey, Turkey B, Dungan. These are the guys, do you know?
Still, we didn't study that.
So different type of method is available. So I did Turkey B. So if you want, I can choose Dungan, LSD, right? Done it, right? Done it. So done it, you know. So then click OK and click OK. In this post-hoc test, LSD, here 1 and 2, the value is 0.003. So the deviation is available, but significant, 1 and 2. 1 and 3, significant. 2 and 1, significant. 2 and 3, non-significant. Which method? LSD, right? 2 and 3, non-significant. But 3 and 1, significant. 3 and 2, not significant. So in this method, it says the 3 is deviated from the first 2, right? In LSD method, it says like this here, 1 and 2, 0.03, significant. 1 and 3, significant. So 1 and 2 and 3 are significant, right? 1 and 2 and 1 and 3 are significant. Then 2 and 1, significant. 2 and 3, not significant. Here 3 and 2, not significant. So the group 3 is deviated from 1 and 2. In which method? LSD, Latin square design, right? In Dungan's, Turkey B and Dungan says the first group is deviated from the last 2, right? Dungan and Turkey B remaining same. First one is deviated from the last 2, right? So this is the way we can get the post hoc results. Up to this, if you have any doubt. So normally in the postdoc test. So depend on the method, we can use Dungan or Donut. These are the methods they use to get the values. Apart from this, if you have any problem, any doubt, so now we can finalize ANOVA test. In ANOVA test, up to now, say, shall I repeat it again? In the analysis, compare means one sample t, so one-way ANOVA. In the one-way ANOVA, so there are two different variables. One is group, another one is exam marks. So exam marks is the dependent variable. So exam marks, we can find it using the training group, right? So training group is the factor and exam marks is the dependent variable. Then we can go to click OK. We can get the ANOVA results. If the ANOVA is ANOVA value is significant, then we want to find out further which class is deviated from the rest, right? Which is the class it's not significant from the other classes. So we want to find out this, we have to do the postdoc test. There are several postdoc methods available. So in the postdoc LSD, Brifonoli, so these are the methods also is Turkey, Turkey B, Dungan, and Donut, right? So most probably we are using Turkey, Turkey B, Dungan, Donut, that's all, right? So you can choose one method in your results. You can elaborate why the deviation is, which class is which group is deviated from the other using the Dungan or Donut or Turkey, whatever method you are used to get what the results. With your results, you can elaborate, right? Select one is enough, not more. You can choose one and click OK, then interpret the results, right? Up to this, if you have any problem, in the initial stage, why we want to go went to graph chart builder? Why we go to choose the chart builder?
Excuse me, sir.
Yes, yes. Tell me.
Sir, the ANOVA table significant irundadana நம்ம அந்த post work test செய்யணுமா?
Oh. If the value is in the ANOVA table, if the value says significant, what do you mean? What do you
0.05 விட சின்னதா இருந்துச்சுன்னு சொன்னா
then only we can go to the postdoc. Which group is deviated from the rest of the group? Otherwise, if you are not rejecting the null hypothesis, why are you want to go to the postdoc test? No need, no. If you are reject the null hypothesis, that mean for that someone is deviated from the other group. Minimum one group is deviated from the other group. So normally the assumption says at least one group is deviated from the other. So one group is deviated from the other, we can accept the alternative hypothesis. That means the significant value is less than 0.05. Then only we want to find which group is deviated from the other. So the null hypothesis is accepted. No need to go to postdoc test, right? So that's why in my practical session also I did like this. So first I try to find the significant value. If the significant value is less than 0.05, we can reject the null hypothesis, accept the alternative hypothesis. After that, I have the issue which group is deviated from the other. That's why I go to check the postdoc test.
Okay,
Okay.
sir. Thank you, sir.
So anyone, if you have any problem, so up to this, right? So frequency table, descriptive statistics, exploratory analysis, so box plot, and one sample t-test, paired sample t-test, independent sample t-test, one-way ANOVA, in addition to that, post hoc test. Are you agree? I did this. Hello? If you are silent, what do you mean? Hello? Okay. We'll see in the next class. So I try to send some link coming Monday, next Monday. In the Monday, we will see with the quiz exam. Okay, okay. Thank you. Thank you. Be patient. Too much of patience. That's the problem. Right? Okay. Bye.